Uh, Good morning, ladies and gentlemen. Welcome to this webinar on system earthing and fault detection in prosumers electrical installations. My name is Chris Theobald, and I'm your moderator for today. Uh, our speaker today is Nandu Gopan, and this webinar has been organized by the National Federation of Engineers for Electrical Safety. Um, Before we begin, I'd just like to give you a little bit of a background about NFE. So, we are a group of passionate electrical engineering professionals working in the field of electrical safety. Our members have got decades of experience in working with electrical inspectors of state and central governments, electrical designers, safety officers, and engineers in the field of both quality and standards. Our vision is to make every electrical installation free of accidents such as electrocution and fire due to short circuits. And we also would like to increase the reliability of the electrical installation, thus contributing to the saving of life and property and supporting sustainable development. Our mission is we should strive to achieve our vision by getting accredited for product and personal certification, something we're actively engaged in getting done, which will focus on electrical safety by design, manufacturing, installation, and maintenance of electrical products and installation by both competent persons and qualified manpower using quality resources, including products, processes, and procedures. Essentially, we want to create an entire ecosystem that facilitates safe electrical installations. Just a little bit about myself. I'm your moderator, or I'm not going to be doing a lot of talking today. Um, I'm an electrical designer. I've done quite a few training programs at NFE myself. That's enough about me. I'll just introduce you to our speaker for the day. Nandu Gopan. Uh, Nandu has a BTech and currently is pursuing a Master's of Science at a University of Witwatersrand. I'm not entirely sure how you pronounce that. With Nandu, how do you pronounce that?
You can just call it WITS.
Wits, okay. And it's in South Africa. And he has delivered a number of seminars and technical presentations. He's also presented papers all across, especially one at ICLEASM, which is the International Conference on Lightning, Electromagnetic, and Semiconducting Materials. He also presented at the 17th International Fire Conclave. You've written an article, which was quite popular, I believe, on fires due to air conditioners causing casualties and a study of how its electrical parameters influence this. And your masters are currently on the subject of hybrid energy systems, which is increasingly relevant and also quite related to what we're going to be speaking about today. Anyways, that's it from me. Nandu, I'd like to hand it over to you, and I'll be
Yes.
here. Yeah.
Yes, Krish. Can you stop the screen sharing? Yeah, okay.
Yep, I've done that right.
So you can see the screen, I believe. Yeah.
Yep, all good.
Okay. So I'll be talking on prosumer installations, system referencing on prosumer installations, and I'll be giving a little more attention to solar PV. So on to the contents. So I'll give a small introduction and then I'll explain about the modes of operation of PEI, prosumer electrical installations, and I'll be going through the problems of PV systems, the topology for earth fault protection in PV system, and the system earthing in prosumer installations. So, a small introduction. Prosumer is a party which can consume and produce electricity, and the PEI, which will be used in this seminar quite often, means prosumer electrical installation. So this is as per the two standards IEC 60364-882, that is for prosumer electrical installation, and for PV, I'll be referring to IEC 63112. So types of PEI. There are three types of PEI: grid connected PEI, islandable PEI, and standalone PEI. Grid connected PEI is where the PEI is only where there is a discom which is connected to the PEA, that is when it will be working only in that condition. That is called grid connected PEA. Islanding PEA is discom can be connected or even disconnected from the PEA installation. That is an islandable PEA, and standalone PEA is where the distribution network is not connected to the installation. Now to the modes of operation, there are two types of mode depending on the how the feeding occurs: direct feeding and reverse feeding mode. Direct feeding, it is these two are pretty obvious. Direct feeding means from the distribution network supplies the PA, and reverse feeding, the PA supplies the distribution network. And there is also another two modes of operation. One is when the PEI is connected to the discom, and if the discom is if it is disconnected and PA is operating on its own in the installation, then it is an island mode operation. Now onto the so these are the four types of modes of operation, and the challenges in PV system. So the problem with PV system is, like, you can't de-energize in the daytime. So if you have a protection, you have to make sure then in only some corrections can be done only in the nighttime, and daytime you won't be able to do any corrections, and you can't disconnect it. And next is low fault current. Yes, in PV system, even if there is any fault, even if there is any like a fault, over current protective device won't trip faster, because there's a the low fault current which is coming in case of fault will be really low. So over current protective device cannot be relied in case of fault in PV system. And next one is the large number of sources. In PV system, in normally for PV array, there will be huge number of PV modules, and the problem is you can't give protection to each and every single PV array. I mean PV modules. You can only give it in a in a combiner box, or you can combine it and give it give protection, but that is also an issue. Next is islanding mode in prosumer installation. This I'll be getting back to you on the like in the last few slides on how islanding mode is affecting prosumer installation. So, so the topology is related to earth fault protection in PV array. Basically, there are three types of earth fault protection. Three types of topologies for earth fault protection. One is functionally earthed system topology. Another one is non-separated system topology, and then last one is non-earth referenced system topology. So these three are the topologies related to in PV system for earth fault protection. And one more thing I want to say in this is, like I am I will not be I will be only mentioning about the system referencing conductor. System referencing conductor is the only thing which I'll be giving importance to. I won't be talking about all the equipotential bonding, the use of SPD. I won't be mentioning about that at all. That is something you are supposed to do, irrespective of what type of system you are going to go. So I'll be mentioning only about the system referencing conductor in this slides. So, so functionally earth system topology for PV array. So functionally earth system topology is where this is a PV source. There will be an inverter, and there will be a separation. There will be an isolator. There will be a transformer, and one of the line conductor will be earthed, and one of the line conductor will be earthed with this over current protective device, or it will be a residual current monitoring device. So this thing which I have marked in red will either be a over current protective device, something, it can be a fuse. According to standard in 0.5 kilowatt, it should be a fuse of a certain rating. So it can be a over current protective device, or else a residual current monitoring device. So, and I will be explaining more on this little more detail. And it can be, this separation can be coming internal to the inverter, or it can also, you are supposed to provide a separation outside the inverter also. So both of these come into the functionally earthed system topology. And in functionally earthed system topology, the earthed conductor earthing will be done only at one point in the DC side, and this side will be unearthed. And from the AC mains, it depends. You can have it earthed or unearthed. It depends on you. It depends on the supplier or the consumer. So this is non-functionally earthed system topology. Next is non-separated system topology. Non-separated system topology is pretty simple. You will have a PV source and you will have an inverter, and the inverter is not separated. The DC side is not separated in the to the AC side. You won't have any you won't have any separation in it. And this DC side will be for earth fault protection. It will be relying on the system referencing conductor in the AC side. AC side, probably in the discom, there can be a transformer, and where the system referencing conductor is done in the discom, that is where the earth fault, that is where this topology is referring to. Now, next, this is pretty common in most of the prosumer installations. You will be able to find non-separated system topology. And next is non-earth referenced system topology. Non-earth referenced system topology means there won't be any earthing from here to here. There won't be any system referencing at all. There won't be any system referencing from for this the solar PV. And from the transformer, yes, it can be earthed or it can be unearthed. That depends. So it can also come without internal separation or with the internal separation. This will be in one PCE. So these are the three types of non-earth referenced system topologies. Now, I will be explaining how earth fault protection is done on each and every single system topology. So the most important in a solar PV, 100% you are supposed to have a double insulation. Even in the combiner box, you are supposed to have a double insulation. That can never be compromised. And the for all protections, they will actually be using they'll be using two devices, a residual current monitoring device, or they'll be using an insulation monitoring device. So by the principles of these two devices is where they have implemented a safety measures that will be detecting the faults and tripping the overcurrent device or whatnot. So mostly you'll be able, 100% you'll be able to see these two devices used in the topologies. So first topology, and the first topology is functionally earthed system topology. In functionally earthed system topology, there is a solar PV, there is an inverter, there is a transformer. And from the transformer, probably it is going to different other consumers, other customers. So this is the discom's transformer, and this discom's AC mains, and this will be going to other customers, and it will be going to the installation. This will be the installation. This will be the installation. So in this, what happens is, you see, in case of fault in the AC positive side, I have functionally earth is done in the negative conductor. So if there is a fault in the positive side, example, yes. So if there is a fault in the positive side, so the current will be coming here. So this is how the current moves, current travels. So there will be an overcurrent protective device over here. And this overcurrent protective device, depending on how much amps it is coming, it will trip. And this, after tripping, it will either it will sense on this one or this one. Now, the thing is, after this trips, this will become an IT source, with the with first fault. So the point in this system earthing is like it will inform the person, the maintenance person or whoever is there. They will inform to him that there is a fault here and you are supposed to rectify it as soon as possible. And this installation monitoring device will also open when this works. So when you want to do any maintenance works, then you will have to disconnect here, and you can this installation monitoring device will also work. And in most of the PV sources, you are supposed to in before energizing and after in the date after the operation, you are supposed to check the insulation monitor for the value of what if there is there any weak insulation or not. So this is how the earth fault protection is done. If there is a in a functionally earth system, if there's a earth fault in the positive side, but if there is an earth fault in the negative side, it can be little more complicated. For example, for example, so this is where the earth fault has occurred. So how the current travels is current will be traveling like this. So the problem is the current will be traveling this, and the current, current IEF, the earth fault current, traveling in this path through the through the functionally earth system depends on the resistance of the line conductor, and depends on the resistance of the R earth. So suppose if the R earth is high, then the current which is flowing through this through this functionally earth terminal will be high, will be low. So if it is low, and if it is low enough, sometimes this overcurrent protective device won't be able to detect it. And if it is not detecting it, it won't trip. And this will be like, there will be a fault. There will be a fault current which will be traveling in the system, but it won't be able to trip. But for this cases, mostly whenever your system is gonna be de-energized, like probably after the working and the night time, a maintenance person has to go to the system, and he's supposed to check the insulation monitor. So if he checks the insulation monitor at that time, he'll be able to know that there is a fault here. He'll be able to know that there is a fault here, and he can rectify the fault. But suppose this R earth is compared to R PV is little lower, then the current traveling in this path will be much more. The current traveling in this path will be much more, and the overcurrent protective device will trip. So only if the current is, if only if the R earth is, the impedance is really large, such that the current sensing is really really the current which is flowing through is really low, and this overcurrent protective device doesn't trip, that is where this problem happens. But even in that case, the current which is flowing through this path will be really low, and if you have done proper equipotential bonding and all the other bondings proper, you won't be getting a shock. Only thing is, when the maintenance guy checks every day, if the maintenance guy checks every day, then he'll be able to know that there is a fault in the system, and rectify it. Now, this overcurrent, the functionally earth terminal it can be of two types. One, it can be of overcurrent protective device, like example of fuse, or it can also be a residual current monitoring device. So if it is a residual current monitoring device, it is pretty easy. So if there is an earth fault, obviously there will be a differential current, and with this differential current, this residual current monitoring device will be acting either on KEV or KPV. That depends on the inverter, and that depends on the designer. So this is how earth fault protection is done in functionally earth system. Now, if you are going to a non separated earth system, in a non separated earth system, in a non earth system, there is a solar PV, there is an inverter, and this will be the discom's system referencing conductor. So the system referencing conductor will be earth. And in this case, and here from the inverter to here till the point of commencement of supply till KAC, there won't be any system referencing won't be done. Equipotential bonding and other protective measures will be done, but system referencing won't be done. And only in the AC mains it will be connected to the system referencing will be done. So in this case, if there is any fault in the solar PV side, what happens is current travels to the system referencing conductor on the discom's transformer. It will travel through the system referencing conductor back to the it will travel to the system referencing conductor. It will go to the neutral of the conductor, and it will go back to the source. It will go back to the source. So in this case, you are supposed to have a residual current monitoring device, and this residual current monitoring device will either act on KPV or KAC. So depending on the topology, wherever the disconnection is required, it can happen. And one more thing is this residual current monitoring device can be either put on the AC side, or it can be also inputted in the DC side. So here it is actually present in the DC side. It can also become in the AC side. I'll explain in the others next slide. And one more thing is insulation monitor is also mandatory here, because insulation mostly this will be kept inside the inverter. So when this K when this trips, when this if anything if the KAC or KPV is disconnected, this insulation monitor will check the insulation between the conductors. So this is how. And one more thing is, if there is an insulation monitor, residual current monitoring device in the AC side, same, if there is a fault over here, again through the system referencing conductor, it will be going back to the source. I mean, it will be going back to the AC mains, and it will go to the PV, and again the loop. So again, this will act on the KAC, or it will be acting on KPV. Now, the thing is, if there is a non-earthed system referencing conductor, non-earthed system topology, this is the third type of topology. If there is a non-earthed system topology, in non-earth system topology, it won't be earthed, it will be unearthed till here. There won't be any system referencing conductor till this transformer. So in that case, if there's a fault on the PV positive, then there won't be any return current. It will be an IT source. Completely, it will be an IT source. And one more thing in this to notice, the insulation monitoring device will be working 24 into 7. Whenever there is a loose, I mean, if there is any weak insulation, this insulation monitoring device will detect it, and it should inform the owner that there is a there is a weak insulation, and they are supposed to rectify it as soon as possible. And if there is a and you are not supposed to have a second fault in the system. If there is any second fault, then it can be pretty complicated. So now the problem is, if you have a solar according to this system, I mean, according to these topologies, if you have connected to a PEI, there can be a problem. So I have taken a non-separated system. I've taken a non-separated system. It is not earth system referencing conductor has not system referencing has not been done in this PV. Only in the discom it has been done. So basically, you can consider this as a TT source. The system referencing is done only in the discom. And the thing is, if there is a fault in the PV, that means in the connected mode is where the grid is also, the discom is also connected to the low. The discom is also connected to the PEI. PEI starts from here. This is PEI. So if if there is a earth fault in the solar PV side, what happens is there will be conductor the conductor earth fault current will be traveling through the earth. It will be going to the system referencing conductor, the TT in the discom. It will be going to here, and it will travel back to the PV. And in this case, this residual current monitoring device will act on it, and it will either work, it will disconnect KAC. So here there is no other problem. But the problem comes okay, one more second. I forgot to explain this picture. So this picture is actually there is a earth fault, and from here is where your prosumer your load and all is being connected. And from here, this is the point of commencement of supply. Point of commencement of supply is from there only the electrical installation is being started, and this is where the probably it is going to other customers. So in these cases, if there is any earth fault, if the discom is still operating, I mean, if the transformer is is still in a good condition, and if the system referencing conductor is still in a good condition, it will go back to the source, and it will the residual current monitoring device will act on the protective device. But the problem is, if this discom, if this supply is not there, if this discom, if it is an uh, islanding PEI, islanding prosumer installation, and this something happens to this system referencing conductor, that is where the problem starts. If that is there, I have removed the this from this area, I have removed in the next slide. So in that case, what happens is, if there is a fault, earth fault in the PV side, since this is a TT system, there won't be any system referencing conductor. You won't be doing it in the point of commencement of supply, only in the discoms transformer. So what happens is, this becomes an IT source. This becomes an IT system referencing. So the thing is, the consumer or the prosumer won't be able to find that there is a problem in this system. There is an earth fault in the solar PV side. So I will be explaining. I'll be in the 2 3 slides. I'll be doing how you can do the changeover of the system referencing conductor in the prosumer installations. So before going to that, I'll just tell you a little bit of what is system earthing. So system earthing is of 5 types. So first is TNC is where the system referencing conductor has been done here. This is the system referencing conductor. The body of the I mean, that is not the system referencing conductor. Sorry. Yes. System referencing is where it is done here in the source. The body of the transformer and the neutral has been done here. And in TNCS is where the C is connected, the neutral and P is combined as single conductor. Next is TNS. TNS is where the system referencing conductor has been done here, and the neutral and P will be going separately to the body of the, I mean, to the load. Next is TNCS. TNCS is where, from the source, there will be a system referencing will be done here. The neutral and P will be connected, neutral and the earth will be connected here. And from here to here, it will be TNC. TNC, where the neutral and P will be connected, will be having a single conductor, PN conductor. And from here, it will start as a TNCS supply. So in this case, if there is any earth fault, the fault current will be coming, it will be traveling like this. Next is TT source. TT source is where the system referencing is done here. Neutral and earth has been connected and it has been earth, and the body of the, I mean the installations MET also will be connected to earth. So this is where this is what TT system is. Now, as I explained earlier, in the non-system referenced conductor, in the non-system non-reference non-separated system, if the discom is being disconnected here, if the discom is disconnected here, there can be an IT system. So for this case, what are you supposed to do? So I'm talking about an LV supply. So this is the image from in the Prosumer electrical installation standard IEC 60364-882. I will show much more simplified image of than this. But first, I'll explain what this image is. Then I'll explain how the changeover happens from the TNCS to TNS in islanding mode. So what happens is, in this there will be the 16 is the Discom's HV transformer. The 15, meaning this whole area, is the prosumer's installation, PEI, prosumer installation. And this part is the main distribution board. In the mostly the system referencing, the changeover of system referencing conductor happens in the 14. Once again, happens in 14. And what happens is here, the discoms the from the discom, the transformer, the supply is coming, the supply is going to the distribution board, supply is coming to the distribution board. And there is also few more sources, 6 and 7. There is 6 and 7 are two more sources. So you can read here, 6 is a local source and 7 is also a local source. So these both also can be, like a solar PVs from the inverter side. So those two are also going to the distribution board. And in the distribution board, as per IEC 62305, there is some overcurrent protective device. Protective device is called NIAN for each sources. These things are overcurrent protective device. And this 10 is where the 10 is a switching device. And this 10A means it is connected to, it is controlled by energy if management systems. So these are switching devices which are controlled by energy managing system. So energy management system will be connected to this part, and this part. Now the more important point in this is actually the most important point in this is this part. This is where the changeover happens. So you can read over here 11 and 3 and 11. 3 is a switching device for islanding. So you can shortly call this as SDFI. So 3 is a switching device for islanding mode. And 11 is a system referencing conductor switching device interlocked with SDFI. Meaning this 11 and 3 are interlocked. So if one is on, other will be off. If the other is off, another one will be on. So these both are interlocked and these both are switching devices. And obviously these two are also controlled by the energy management system. So this is how and how it will look in a overview. Now I'll simplify this diagram into, I'll take these overcurrent protective devices out and I'll make it a much more simple diagram. So this is how it looks, a little more simplified. So this is from the discom. This is source 1 and this is source 2 inside the PEI. This is the PEI. And this actually should be in the distribution board, the main distribution board. So from the discom, there is a it is a TNCS in connected mode. So meaning from the discom, it is a TNCS conductor is coming. So there is a four live conductors are there. System referencing has been done here. The neutral and the PE has been connected here, and neutral and PE is connected here. And from the in the installation, four conductors will be coming inside. So in this case, I will consider this off. In connected mode, I will consider this off, and I will show how TNCS is done here. TNCS is, I'll take these things out. I'll make it much more simplified. So in this case, so this is off. So this conductor is not there. This conductor is not there. So what happens is T is done here. The system referencing is done here. This is the PN conductor. The neutral and the earth is connected here, is coming in this single line, and this single line is actually being connected to the PE, of the installation here. So this is also a system referencing conductor. This is where the TNCS from here, this is a TNCS. The TNCS from here is being changed to TNS. So this is TNS. So this the system referencing has been done here. So here, from here, it will be a neutral conductor, and this will be a PE conductor for the installations. So what I mean is, in simplified term, this will be a PEN conductor. On top, this will be a PEN conductor, and from this PEN conductor, there will be a system referencing done here, and from here it will be neutral, and from here it will be a PE. So this will be on and this will be off. So this is how it is. It is in TNCS. This is in connected mode. In connected mode, how this is a TNCS system. Now, what happens is, what if okay, what if how does it change to a TNS system in islanding mode? In islanding mode means uh, this system won't be there. This transformer won't be there. This discoms transformer won't be there. So we can ignore few things. Example, like these things that we can ignore. And since this is an islanding mode, this will be in off and this will be in on conditions. So we can take all the things which is there on the top. From here, we can take everything outside. So what is being done here is the neutral, and this is the system referencing conductor. This is the system referencing conductor of this source. So the source and the earth should be system reference, right? So what they do here is the system referencing conductor is being connected in this area, and from this area this will be a PE, and this will be a N. This will be a neutral conductor, and this will be a PE conductor. So this will be the system referencing conductor, and this will be on and this will be off. So this will be a perfect TNS supply, and from here everything is TNS supply. From here everything is TNS supply. So from here everything is TNS supply. This will be in islanding mode. Now, what happens if, so this is how it is, the system referencing has been done. So mostly I'll just brief it little shortly. This interlock, which is happening between 3 and 11, will decide on how the system referencing is done in in this mode, in this connected and islanding mode. Now, now, one second. Okay. So in what happens if there is a TT system which is coming from here? The discom is providing TT system, and in islanding mode, this should work in TNS supply. Then how does that work? So I'll be explaining on that. So this is the, I'll like the previous image. This is the discom. This is the like the local producing some sources, and this is the main distribution board. And here the system referencing conductor is this 3 and this 8, this 11. This is where the system, the changeover happens. So in these cases, what happens is I have simplified the above diagram. So in these cases, I will. This is it in TT in connected mode. This will be a TT system. So what happens is there will be a transformer. Discom is working. This is in TT source. So this we can consider this off. We can consider this off. There is already a system referencing over here. The T is already done here. And since this is off and this is on, we can take these things out. We can take these things out. So what it shows is T is done here, and this the P of this installation, the P of this installation has been connected to another earth electrode. This is another T. So this will be a TT system in connected mode. I'm taking these sources out only for simplifying the diagrams, because you are supposed in connected mode PEI, the according to how the energy management system works, the sources will be there. But I'm just explaining the system referencing conductors. So in this case, it is pretty clear. So this will be on. So this will be off, and this whole conductor won't be there. This whole conductor won't be there, and this will be a TT. So all the the exposed and extraneous conductive parts is connected to a earth electrode, and the neutral of the transformer and the the protective earth of the transformer is also connected to the earth electrode. So TT system. Now in this case, how does it in this how do we change it to a TNS supply in case of islanding mode? So in islanding mode, you can take these things out. You can in islanding mode, this will be off. This switching device will be off, and this switching device will be on. So I'll take these things out. The discom transformer, I'll take it out. So in this, the transformer, I mean not the transformer, the local source. In from local source, 5 wires are coming. So this 5 wires, it will be coming, and in the main distribution will be like this. So since this is off and this is on, this is where the system referencing has been done. The neutral of the conductor and the P of the installation has been connected here in a single point. So in the for these cases, so if since this is connected, the P of the installation and the sources has been connected in one place, and that has been not that has been connected. This becomes a TNS supply. So there is only one there will be only one connection, and there won't be any other neutral 2P system referencing won't be done anywhere in the system. Now I'll go to the conclusion. Actually, this subject, this prosumer installation subject, is actually a pretty big subject, and I have only tried to simplify the subject as much as possible, and I have only simplified the system referencing conductor on the system. I have not explained about how the equipotential bonding and all those things does. Like generally, if you follow a normal IS 732 or NEC, that and all will be done properly. But the problem is this system referencing changeover will be pretty complicated in prosumer installations. So the main issue of this is with the discoms. So what I've written here is the discom, if he supplies as per regulations, if he supplies a TNCS supply, then most of your issues will be TNS with TNCS with PME, meaning there is an earth electrode in your installation. If that has been done, then most of your issues with respect to this prosumer installations will be solved. But in most of the areas, they have supplied a TT. So if they supply a TT system, then your installations can be, if you want to change from a consumer to a prosumer, it can be really really complicated. You should have a system referencing conductor, and how I explained it in the previous slides, you are supposed to change it. Now, so this discom should decide on how what type of fault detection is done on the prosumer installations, because if they give TT or TNS, TNCS, it will differ. Now, another important thing is, in if there is a fault in the solar side, you normally, if you know in if you use as per IS 732, then you will get selectivity from, if you size your conductors overcurrent protective device properly, you will get selectivity, and only the where the earth fault is there, where the fault is there, it will be isolated from the other system. But that won't be possible in the PV area. So what happens is, here they will be trying to find if there is a fault, and we are supposed to rectify it as soon as possible. That is the only possible thing in a PV system. So if a fault is not detected in a consumer's premise, prosumer's premise, it can lead to fire. So if you don't have a installation monitoring device, normally in inverters they give installation monitoring device, but in most of the areas they don't provide that. If you don't have that, then it can be complicated. So this is, so if you don't detect any fault, then it can lead to fire accidents. And if you use a wrong system topology, so suppose in case of you know if the neutral of the conductor is not being done properly, and if you know wrong, if you select a wrong system referencing conductor, wrong system referencing topology, and how the changeover happens, if you select those two, if you don't coordinate it properly, there can be backfeed from the PVI to the grid, and that can create issues not in your installation but also in others installation. Probably if there is any other nearby consumers of the discom, then it will be creating issues in their side. Now now that is the third point. Now, next one is the neutral isolation. I have explained in the previous slides that most of the fault current in the non-earth, non-separated system will be flowing through the neutral of the conductor. It will be flowing through the system referencing conductor, and then it will be flowing through the neutral of the conductor. And if you have isolated the neutral of the conductor, I mean, if you have by mistakenly, if you don't know how to select it, and if you have isolated it, then the detection of fault as per the topologies won't be done. And in some cases, instead of using for suppose for functionally earth system system topology, if you have, instead of separate, you are supposed to separate neutral. If you have not separated neutral, and you have only separated the three phase conductors, then also there will be a problem. So this is what is there in the third point. Okay, here it is. So this is what is done in the third point. So system isolation should also be looked into it really, really carefully. Now, the supplier should also, like from the discom, the discom should also provide documentation on how they decide system referencing. And as how I have explained in the first slide, this is quite an important thing. If they have said what they are doing, what type of system referencing conductor they have done, then you can do a proper prosumer installation. So this is how I'll finish the session. But obviously, the problem with this is I have rushed up few slides. But the problem with prosumer installation is, if you don't coordinate it properly, there can be huge fire accidents in case of fault. So you won't be able to see the faults, you won't be able to see the fires now, but you'll be seeing the cause effects of it in probably in 6 5 6 years, when the installation deteriorates, and all those, when those issues starts to come. So whenever there is a prosumer installation is done in if there is if a consumer wants to change to a prosumer installation, he has to do a lot of issues. And I have explained in this slide, I'm repeatedly telling, I have explained only how the system referencing has been done. I have not explained how the equipotential bonding or other things are done, because those are already mandatory. So so probably we can move with the question answers. Krish?
Yeah, I think thanks so much, Nandu. We have about 100 and almost 100 participants who watched throughout. So, yeah, we'll just take the questions in the Q&A. First question is from uh, MEC Shanley. The question is PV structure, earthing method, and mandatory practice information details, sir.
One second, where is the question? I'm searching.
Yeah.
PV structure, earthing method, and mandatory practice details. Actually, this is not what the system is about. But what you are supposed to do is you are supposed to have an MET. You are supposed to have an MET, and you are supposed to interconnect all the exposed and extraneous conductive
Better,
parts of the
better you
installation
show
to the
the
MET.
better you show the slide which
Yeah,
was
yeah,
there
yeah,
in
yes,
the presentation.
yes. So let's show this slide. Yeah, sure. So, so this is how it should be done. It's not coming. It's cut. So this is how it is supposed to be done. So in a prosumer installation, you are I mean in any installations, you are supposed to have a EQ, an MET, and the MET should be connected to all the exposed and extraneous conductive parts. This will be a body of the inverter, body of the probably the PV module, the all the other metal parts. You are supposed to connect it to the MET, and from the MET also, as per the, it should be connected to the lightning protection. So this is how the earthing should be done. So
Great.
next question is,
The next question is on the DC in the DC side, earthing negative is grounded at the inverter and protects against positive grounding by operating over current device. What if negative conductor has ground fault? I think you answered this, right?
yes,
Earlier in the
I think
webinar
I've
itself.
already answered that.
Yeah.
I've answered in this one. Yes.
Yeah. No, that is that no, he's saying what if the fault is also on the negative side? That is the
On the
next slide, I
negative side,
think.
I've
Yeah, yeah.
explained here.
Next slide. Yeah, you explained it there. Yeah. Most of the discom engineers demand for separate earthing of AC and of DC and AC. Is this correct? Please share your inputs.
That is what I'll explain here again. Uh, it should be connected equipotential bonding. It, you are supposed to do it. The AC, the earthing, earthing in AC, and you are in DC side, you are supposed to connect it. That's it. And if they are asking, you are not supposed to do it, then in case of any fault, there will be potential differences, and you will be getting shock.
I mean, the key thing is that if the system is not galvanically separated, then there should be only one system referencing conductor.
Yes, 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 yes.
And if
Actually,
there is, yeah,
yeah, in this in that question, you can divide it into two parts. One is one is system referencing conductor. System referencing conductor, you are depending on what type of topology you are supposed to do it. You know, if there is any galvanic separation, then you are supposed to do it. Then you can or you might not do. It depends on the topology. But the other one is the equipotential bonding. Equipotential bonding must be done. You should
hmm.
not have a separated thing. Yeah. Next question
Next
is.
question is, yeah, can we get any case study for an existing installation to be modified as required type of earthing system needed? This is the one which is lagging with professionals.
Probably in the upcoming some webinars, we will be able to take some existing installations, and we can show how what is wrong and what needs to be done. We can
Yeah,
do that.
perhaps that is a subject for a separate webinar entirely.
Yes. Next one is
Separate AC and DC earthing has become a cardinal practice without understanding the type of system earthing. Even discom engineers are following this blindly. Can you share some general guidelines or thumb rules that can be followed? I don't think
Actually,
general guidelines or
I
thumb rules are a good idea in any case.
I can't give any general guidelines or thumb rules, but basically, because you see, there are three types of topologies you are going to go, and there are different types of uh, what type of earthing you receive from the discom. So there are, the case studies are large. If I want to give some thumb rules, then it won't be applicable for the other type of system referencing conductor, other type of topology. So I can't give some general thumb rules. Sorry.
Unfortunately, the industry tends to veer towards things like that, but it's a very vast industry, so you can't really go by thumb rules. Um,
Yes.
our secretary from the Mumbai chapter, Ms. Pallavi, is asking, your last point is in conclusion, is this part of the statutory compliance? And if not, we as NFE can make efforts to include it.
Actually, in the regulations, they have told you are supposed to go with TNCS with PME. If you have a TNCS with the PME, then most of the system referencing conductor, you don't that issue won't be there. Even in case of discom, if there is any problem with the discom side, since there is a PME which is done in the installation in the point of commencement of supply, that won't be there. So if they follow a regulation, this will be easier. And also, in the one more point I have mentioned in this is insulation monitoring device has not been kept in a lot of places.
Hmm.
So in the regulations, they have told you are supposed to have an installation monitoring device also. So mostly, if you follow the regulations, that will be mostly covered. But the type of system referencing conductor and all those things, they give a much more clarity. I mean, not type of system referencing conductor, type of the topologies you are supposed to go. If they clarify on that, it will be much better. Probably enough we can write something on it.
Yeah, I think that's something for the local chapters to initiate as well. Yeah.
Yes.
There's
So
some questions in the webinar chat box as well, if you would like to
okay.
address them.
Okay.
First question is, um, for non-isolated topology, the RDC is in the AC or DC side of the inverter.
That depends.
I,
I mean, RDC,
I
residual
mean,
current.
there is a residual direct current detection device. I don't think they're referring to that. They're referring to residual current device. I'm assuming it's a typo.
It depends on the inverter. It can be on the AC or in the DC.
I would say though, Nandu, that there are no current standards there are for which products are being manufactured commercially for residual current devices for DC, are they? There is a IEC technical spec, but there is no.
No, but that will be inputted. Then it can be on the If there is no things like that, then it can be on the AC side.
I mean, maybe a residual current monitor, but a residual current device itself, I don't think is commercialized for DC.
I don't know about that.
Yeah, okay, no, fair enough. Yeah,
That
yeah.
can be a
But
part of the
mostly this,
inverter. You don't
Sorry.
need to put it as, you don't need to put it as a separate device, but it can
it
be
will
a
be
part
inside
of
the
the
inverter.
inverter.
Okay. It's a function built into the inverter. Fair enough.
Yes, yes, yes.
Next question is, do you not use second class conductors on the DC side in India? I'm not entirely sure what that means.
I don't understand that. Okay.
Yeah,
You are supposed to use a double insulated, but I don't know. Second class conductor, you mean class two conductors? I don't understand.
I don't know either.
Okay.
Uh, yeah. Do we need to do separate earthing for inverter? I mean electronic equipment earthing.
Uh,
I think
I am repeatedly, I have explained that also in the previous slides. You are not supposed to, it depends on since this is an inverter question, it depends on which type of topology you are going.
Krish, if you allow
yes,
me,
And
I will make
yes,
a
of
small.
course. Please,
uh,
please, please.
you see, once when prosumer installations comes into picture, the type of challenges which we are going to face is a totally different. New challenges are going to come. The only accepted, technically accepted method of earthing in solar PV is as shown in the figure. The PV frame, the DC side, AC side are connected to a common MET, and the MET is connected to, for example, a TN system neutral of the transformer or whatever, a proper system earthing. So everything interconnected, and the resistance of each of the connection shall satisfy certain maximum value. It should be a firm, very good connection. It is not like you route a long cable and make a connection. No, it should be a proper interconnection is what is accepted, included technically in the standards and all technical books. But unfortunately, 90 percentage, or a majority of the electrical solar PV installation in India are operated with or are made with a wrong idea. Engineers believe that earthing means a plate or a pipe in soil. As a result, DC side is connected to separate pit in soil. AC side is connected to separate pit in soil. Lightning protection is connected to another separate earth electrode in soil, and actually they make the whole installation a kind of a non-compliant installation.
Yeah.
Making this separate is, the simple word is, it is illegal. It is wrong. You should go to the standard or the picture which is shown during the presentation, and you should make an interconnection. That is the only correct method for the proper functioning of the system. Now, once when you have a proper earthed system, then you should find out what kind of system referencing means, how to detect the fault and how to protect the installation against fault is the second question. Very important question. If the first itself is not correct, then naturally the second also cannot be correct. The result will be unnecessary failures of electronics and unnecessary failure of or unnecessary fire accidents in the prosumer premise. In future, we will have thousands, millions of prosumer premises. And if we go with this current way of installation, especially without double insulated wires, without compromising the requirements of double insulation, situation can be different. A lot of accidents may happen. So it is high time that the first is the distribution company. They should make a document and they should follow the document and explain very clearly the kind of system referencing or the kind of system earthing which they are supposed or they are giving to the consumer or prosumer premise. Based on that, the inverter supplier or the PV supplier or the integrator can decide the correct topology and implement it in the building. Currently, the problem is neither the DISCOM nor the installer are aware of this particular subject. So if we go in this fashion and if we don't improve, the amount of accidents are going to be more. So we cannot afford to have, we need to have a reliable solar PV connection. That's all
Yeah,
from my side.
absolutely.
Thank you.
Actually, probably NFE probably can do a video, probably a webinar on earthing and bonding and lightning protection on solar PV.
I think there have already been some done, right?
Yeah, but in my slide, in my slides, I've only showed about the system referencing conductor. I have not explained what
Ah,
is
yeah, yeah, yeah,
equipotential
yeah.
bonding.
Okay,
I have
okay.
not explained how do
Wish,
do you
if,
need separate or same earthing. I have not explained those things.
if any of the participant wanted to talk, you can allow them to.
Okay, we have a couple more questions. Should we address those first or should we open it up right now?
We can address those fast, pretty quick.
Okay, I think, okay. Or wait, there are two gentlemen that have raised their hand. Perhaps we will ask them to join as well. One moment. Uh, ask to Mr. Balu G, could you unmute yourself, please? Okay. Perhaps he's not able to. Mr. Ravikant Reddy, would you like to unmute, please? I'm not entirely sure if why they are not able to unmute. Arya Sharma, would you like to unmute, please? If you're unable to mute, please put it in the chat box. Unmute, please put it in the chat box. Mr. Amritlal, are you able to unmute? Yeah, you are
Yeah,
able to unmute. Yeah, sure. Please go
yeah,
ahead.
yeah. Yeah, good morning. Actually, unfortunately, I could not hear what you have actually taken up. My only thing is we have one IS 16997 for rooftop solar
Yes.
installation.
Yes.
So, could we just follow that and do the installation? That will solve the most of the problems. I mean, the
Yeah.
ambiguities
Yes, but the
and the
problem.
ground mounted photovoltaic power plants, there is a guideline TS 62738.
Can I start?
Yeah, the seminar was based on this, or you have
No,
taken up something else?
no. Seminar was based on the solar prosumer installations and the solar PV. So on the first part, the problem is if the discom has not given a proper, system referencing conductor, then only these issues will come. If they have done that properly, then what is given in the standards can be done exactly, can be done properly.
Okay.
Mr. Amritlal, one question. What is the system referencing, the type of system earthing given by the Kerala State Electricity Board in Kerala for low
For
voltage consumer, for low voltage consumer premise?
it is on the TT only. There is no difference.
But in TT, at the distribution, neutral is not supposed to be earthed, whereas in Kerala, neutral is earthed at the distribution. So it is not TT.
Distribution lines actually they are not earthing nowadays. It is only on the transformer side they are earthing. And in case where there are complaints regarding this neutral earth voltage problems, so they simply earth it near to the consumer premises.
Correct. In that case, what what exactly it is? What kind of system earthing? Is it a TT? No, it's not a TT.
That is a different question actually, but usually it has to be, I mean, it is usually done as TT, and sometimes it goes into TNC like that. We cannot predict actually.
It is not a TT then. It is some weird TT with PME sort of arrangement.
Yes. Yes.
Okay.
Uh,
Okay.
we can't define. Usually it is TT. So on TT, I think the problem is, as you said, it is the solar installations are done usually by non-electrical guys.
Hmm.
All the trading people are now doing solar installation. So they don't know what is right and what is wrong. They simply go and do, as you said, lightning arrestor separator thing. There will be unnecessary lightning conductors on a very small house also. And the frame will be earthed in some other earth width, and SPDs will be in some other. So these types of things happens because somebody is there, some license person will ultimately sign without seeing the site. So the problem is there, definitely.
Yes.
Yeah, thank you. I think there are some other gentlemen and ladies who also. Mr. Balu ji, Mr. Rajender Singh, are you able to unmute? Mr. Rajender Singh, yes, please. Yeah, Mr. Singh? Okay. Meanwhile, Nandu, there is a
Probably there are few more questions we can address that.
yeah. So there is I believe okay that GK is answered. Um, Okay. Shall we keep isolation transformer at load side of inverter or supply side or both end? You can't use it on the DC side, obviously.
Yeah, you can give in the load side, in
Yeah.
the AC
Well,
side.
in the AC side. Yeah.
Yes.
Unless, I mean, if it already has a built-in isolation transformer, then no
Then you
point,
don't
right?
need. Yeah.
Yeah. Uh, Data center client don't want to make tripping or cut power supply to IT racks in case of ground fault, but we have to go with TNS system. How to tackle that? I think next week they are doing a webinar on data centers, right?
This
Yes.
question is for next week.
Yes.
Yes.
Uh, can we make a model document for Discom?
Probably yes, but even if we make, they have to do.
Mm, yeah. Some
Yes.
more questions on the chat. Uh, okay, that one we've done. Uh, can you please say some occurrences happened due to wrong methods?
Shock and
Shock, fires.
fire.
Yeah. I think Mr. Gopakumar has also shared that video of the guys dousing the flames on the solar PV installation and it just doesn't go out, right?
Yes. And one more thing is in what I have explained is about system referencing conductor. If you have not done a system referencing conductor properly, your first fault will not be detected. And in
Exactly.
case of second fault, your installation is pretty much, I don't know what will happen.
Mm,
See, already the double insulation is compromised. There is no proper
Yes.
double insulation rules followed in the PV installation. And under that condition, first fault can naturally create, more problem. And it's already happening.
Yes.
If you
mm.
if you look at the fire, most of the fire accidents happening in the solar PV, it's all because of some insulation faults. So here, Mr. Sanjeev Kumar is asking, he has put on the chat, Discom asks separate lightning arrestor for each installation and the subsidy is not approved. So Discom
Mm.
will give subsidy only if there is a separate lightning arrestor for the solar PV. Mr. Sanjeev Kumar, probably we have to give a Nobel Prize to this Discom. To the technical head of this particular Discom, we have to invite him and give an award for this special award. So sorry to make this comment because we are making so much effort to educate the market, making documents, publishing standards. We are supporting BIS to publish standards, but nobody is reading it properly and implementing it properly. This is the point.
There is somebody that has asked, Mr. Rajendra Singh, can we connect HT side PE conductor with MET?
Apav sir, you can.
Suppose as
It's
Sir, you have
muted
to unmute.
actually.
Am I audible
Yeah,
now,
he's
sir?
on. Yes, you
Ah,
are.
thank you, thank you. Good morning, everybody. Nandu, you have given a very wonderful presentation. And the repeated question doubt are arising from the participants are whether the system referencing of DISCOM will be perfect, how to check it. It's a very long issue. I can say that we are almost celebrating the 100th year of non-compliance of Regulation 18. It's not known whether the consumer will be connecting the earth terminal to the supplier's one is not known, and whether the supplier are observing PME is also indefinite. With this situation, we are already losing 14 to 15,000 lives in the country every year. And with the with the renewable energy sources, I don't know what will happen. We can't always be producing what do you say, the guidelines, because unless there is a bill, they will seek for the guidelines. It's not the marketing. The NFE should alone do the. Of course, we can have the guideline. There is a knowledge pool available here. We can do it. But where to sell it, who is going to purchase it, our knowledge. That's the issue. Neither the discom nor the consumers, they are, once the problem arises, only they are coming into picture and raising their voice. So it should be an ongoing process to be built up, and everybody should be participating in this. I hope we can send a write-up on the prosumer installation also. Nandu has come out with a very good presentation. I hope NFE can do it. Some guideline with reference to the regulations and standards. Let them use it. It is our, let us do it, whether they use it or not. We will do it. And I hope our President, Mr. Gopa, will also approve my thought. So it's right time that we should make it and have it. It's the right time also for the consumer and the discount to utilize the best possible solution in the upcoming prosumer installation as well as the existing consumer installation, to be safeguarding the people as well as the property against life and fire, electrocution and fire. With this, that's all, Mr. Nandu and Krish.
Yeah, thank you.
Thank you.
Thank you, sir.
I think, would you like to also, Mr. Appa, answer the question on can we connect the HT side PE conductor with the MET of the installation?
P conductor with MET of the installation.
Yes,
Hello?
the HT side, yeah, HT side PE conductor.
I am not able to understand. P conductor, the ST.
There will be a protective earth conductor on the HT side of the installation, on the HT side, coming on the high voltage side of a network, right?
Okay, okay.
So can we connect that to the main earthing terminal of the low voltage installation? I believe
Yes,
that
yes.
is the question.
Yes, this is another one of the important, very important point that is often getting confused. Even after taking so many webinars on this specific subject, people are still confused. There is a protocol under ISIEC regulation, ISIEC standard 61936 part 1. Is especially a specific class 10. Class 10 is devoted to that entire issue. But finally, it all depends on the integrity of the supplier's discom system. The thing is, even before the evaluation of the standards, codes, everything, it was envisaged in the year 1937 itself. Consumer PE conductor should be connected to the supplier PE conductor or the consumer's own transformer connection. So that means the transformer and the discom connections should be of integrity. They should have maintained their own integrity. Of course, consumer transformer, it is under our control, we can maintain. Then what will happen for the LT consumers who are dependent on the supplier's transformer? They don't know how the neutral and body are interconnected at the substation. So, yeah, 100% safety will occur because of this interconnection, neutral and body at the substation, as well as the TNS from the consumer installation, which is interconnected to the substation. So, if the conditions are not met as per ISIE 61936, certain places you have to separate. So it all depends on, unless you know the conditions, you can't do it. But the most of the thing, combining the thing should alone be done, and you should combine it, for which you may require equipotential bonding and perfect interconnections, including the supplier installation. You have to interconnect it. Ensure your own equipotential bonding as well as the suppliers configurations, setting configurations. Thank you, Krish.
Yeah,
Yes,
sure.
sir.
Thank you. I think there is one last question, Nandu. The question is recommendation of the inverter suppliers with regard to applicable earthing configuration is not uniform. It depends on the country of origin. Any deviation result with warranty issues. Okay, this doesn't seem like a question. It seems like a statement in any case.
Yes.
Would you like to
But
reply
the
into it?
point is, you're supposed to, if we make it uniform in India, then it will be much better in future.
No,
Yes.
of course. It has to be uniform amongst the same country. Yeah. I think if there's nothing else, we can conclude for today. I think Mr. Yalaling, of course, has a question. Let me see if I can get him on. Yeah, he's.
Hi,
Uh,
hi,
yeah, hi,
Krish.
hi, hi, hi,
Hi,
hi.
Nandu. Great presentation. Good
Thank you.
information also. Just wanted to answer the previous question. The statement that came, no inverter manufacturer tells them specifically that the earthing has to be done. They clearly mention in the user manual and warranty conditions that it has to be as per the local guidelines. There is nothing uniform, even if the inverter is from a certain country. So it has to be as per the local guidelines only.
Yeah, thank you. I think it was
Then
nice to hear
that
from
makes it even more complicated.
Yeah.
Yeah, anyways.
Yeah, it's interesting, but that's where the whole idea of international standardization comes from, right? That the products are manufactured to a certain spec, and the installation should also be done to a certain spec.
Yes.
All right. Shall
Okay.
we conclude for today then? I think there is
Yes.
one
Yes.
one moment. There is one. Somebody asked one question here. Where is this? This one.
I don't
I
see any
cannot.
questions.
Can you view this? One minute. Hold on. I don't. Okay.
No, there.
No questions. Okay. Sounds good. Thanks.
No questions.
Okay.
Yes.
Brilliant. Thank you.
Thanks to all. Lakshmi, you can close.
Yes. Uh, Thank you, Nandu Gopan, and thank you, Mr. Krish, for giving
My
valuable
pleasure.
insight. And thanks to Mr. Appavu, sir, also, and Mr. Gopakumar. Thanks for joining. Thanks for all the support. So, hope to meet you all next week. Thank you all.
Thank you.